Hello everyone, is my screen visible? Okay, so let's begin then. I am Mukul Jain, head of the programming club and your tutor for today. And today's topic is searching and sorting. So the goals for today are will be understanding searching. We will learn prefix sums, frequency arrays. We will understand sorting, then sorting based on some custom comparators. And if we have some time left, we'll also understand binary search. All right. Uh, so what is search? All right. So is it visible now? ठीक. So what is searching? Searching is the process of finding some information in a container depending on some conditions. So searching is predominant in CP problems. Now there will be times when you will have to search a few things within an array or a map or a set to get what you need. So if I were to ask you that there is an array of integers and you have to find a number 5 in it, so that is what searching is. Other than searching, there are methods like prefix sums, frequency arrays, and binary search, which are used to solve such questions, and we will be seeing them as we progress. So let us start with the searching time complexities that we see in our data structures. First of all is an array. All right. So in an array or a vector, you can find an element in O of n time complexity. So is everyone clear with how we are getting O of n time complexity if the length of array is n? हाँ, loop चलेगा and it will traverse all the indexes and it will tell at which index is the answer. So the worst case time complexity in that will be O of n. Let's say the array is sorted now. In that case, the time complexity becomes O of log n, and this will be seeing in binary search. So that is reserved for later. Then we have unordered map. Unordered map uh, is a map of key and value pairs. So there is some key, there is a value, and you need to search for a key in that. In that case, you have a find function which the STL offers. STL in CPP offers, and you can get the using that find function you can get the key in O of one time, that is constant time complexity, but this is on average, and in worst cases that can even go up till O of n. So although we consider it as O of 1 only, even though it is O of n in the worst case, but we will think that it is an unordered map, and the find function will give the key to us within O of 1 time. Similarly, there's a map. That is a map is an ordered one. So in that case, the time complexity is O of log n. And similar to the unordered map, we have unordered set. In that too, we have the time complexity O of 1, which is using the find function which the STL offers in CPP. And the set we have O of log n, analogous to the map. Today our main focus will be arrays, and yeah, go on, whoever. Huh, map has a time complexity of log n then. uh, we will be covering this in the next session that will be based on STL. Actually, map is made using balanced binary trees, and this is just to give an overview to you that when to use what. Like, you need something to search in a time complexity of constant time complexity, then you will have to go for unordered map and not map. Let's say you need something ordered, then you will have to go for map only, but you have to consider its time complexity as well. All right, today we will be focusing mainly on arrays, and if time permits we will also focus on sorted arrays and unordered maps and maps. All right, so the first topic today is prefix sum. Now, the classic question of prefix sum is that if you are given an array, and if I were to ask you that what is the sum of elements of array from L to R, that is from a range L to R, then you have to tell the answer within O of one time complexity. So let me give you an example. Let me start with an example for that. Now consider that this is an array. All right, and I ask you that you have to give me the sum from 5 to 4, that is 5 plus 2 plus minus 2 plus 4, and you know the answer is 9, right? Is everyone with me? All right, so if the answer is 9, then it took us, if you see the 4 iterations, we add 5, then 2, then minus 2, and then 4. And considering that the time complexity for this will be O of n, but the question asks us to do it in O of one time complexity. So if I were to simplify it a little, what you can think of it is like you had your mid सेम्स, राइट? मिड सेम्स के वक्त बहुत ज़्यादा लोड हो जाता है बच्चों पे, और बहुत सारे पढ़ाई भी करनी होती है. अगर उसी के साथ आपको और बहुत काम करना हो तो क्या करोगे? आप पहले से अपना काम करके रखोगे ताकि मिड सेम्स में आपका लोड कम हो जाए, प्रेशर कम हो जाए, और आप मिड सेम्स पर फोकस कर सको, राइट? सिमिलरली इज़ द केस विद प्रीफिक्स सम. मुझे बाद में टाइम कॉम्प्लेक्सिटी कम करनी है, तो मैं पहले से उस पर कुछ प्री प्रोसेसिंग करके रखता हूँ, एंड दैट इज़ वॉट प्रीफिक्स सम इज़ ऑल अबाउट. So prefix sum stores the sum of the prefix of an array at each index, and it takes O of n time complexity to compute. यानी कि वो पहले एक O of n time complexity it will take to pre-process that array, and when we ask for a sum of elements of array from L to R, it can answer us in O of one time complexity. And how we define a prefix sum array is prefix of k is sum of array from 0 to k. Now if I were to ask you the sum of elements of array from L to R, what would you do is that you will take the sum from 0 to R minus the sum from 0 to L minus 1, right? So is it making sense to everyone? Alright, so what happens is I'll take the sum of array from 0 to k, that is L to R, and then I have to find the sum from L to R. So what I'll do is I will take 0 to R minus the sum from 0 to L minus 1. That gives me the sum from L to R. Let's go on to the next slide and I'll try to show you. Can you see this? Here prefix sum R minus prefix sum L minus 1. This will give me the sum from L to R. Alright. Okay, So how do we implement that? This is the naive implementation that it takes O of n square time. And what will happen in this, that you will calculate from 0, you will first calculate from 0 for 0, then you will calculate from 0 to 1, then you will calculate from 0 to 1 to 2, then you will calculate from 1 to 3, sorry, 0 to 3, then 0 to 4, and so on. But this takes time complexity O of n square. And an important part which we are missing in this implementation is that the sum from 0 to 4 will be the sum from 0 to 3 and the fourth element, right? And this is the implementation in O of n time complexity. The first element is the 0th element. The next elements are added upon those elements. That is, the 0th element is the 0th element of the array. The first element is the sum of the 0th element. That is till now what we have got the sum as. And then the first element. So I minus 1 plus a of I. In the second iteration, it will be the sum till first element plus the second element of array, and so on. So from the diagram, it will first take 0, then it will be, like here it is 3. So first of all it is 0, then 3, then adding these two both, it will give us 8. Then 3 plus 5 plus 2 is 10. Then 3 plus 5 plus 2 minus 2 is 8. Then we add 4 again, 12. Finally 13. And that is how it works. Now if I've asked you, oh well, it is totally depending upon you and the need of the question. You can also neglect it. In some cases it is not neglected, and that is totally depending upon you. Alright, so if I were to ask you that the sum from 5 to 4, that is from this here to here, the answer that you will give is 12 minus 3, right? Yeah, absolutely. You would have neglected this and you would have started from here. So next we will go on to our second method. What it is frequency array map. Now what happens in some of the questions is you are asked to find the frequency of how many elements there are. Like for example, you are given an array 2 3 3 2 1, and you have to find that how many times 1 appears, how many times 2 appears, how many times 3 appears. Alright, the output would be something like element 1 appears once, 2 is twice, 3 is also twice. So what happens here is that if these numbers are quite large, let's say in the range of 10,000s or even lakhs or above 10 raised to the power 6 order, then you would not store them in an array. You will store them as key value pairs in a map. Like for example, how would you store this array as a frequency of maps is like there would be key 1, the value would be 1. There would be a key 2, the value would be 2. There would be a key 3, the value would be 2 again, because there are 2 times 3 appears in this array, 2 times 2 appears in this array, and 1 time 1 appears in this array. Alright. Yes, that is what is meant by frequency. So frequency is a map that stores the count for each value, that is how many times a particular value appears in an array. All right, so 1 appears 1 times, 2 appears 2 times, in that array 3 appears also 2 times, maybe there would be any other number 5 that could have appeared 6 times. So you will have to store all of them, and that is required. When we will go on the questions, you will see that why is it so. But for now, consider that this is a frequency map, and this is required in some questions, and it is useful when you have to count, you need the count of each characters, and it is required many number of times. All right, am I making sense? Yeah. No, I'll come upon that. So what happens is, like, you have how would you store them? The first question is, how would you store their values? There could be two types of answers. That is, you can store in an array where this particular element, the value of the particular element becomes its index, and the count of the number of times that element is appearing in the array becomes the value of that another array, the frequency array. So uh, let's start. I will show you here. What I mean to say is that there is an array, and consider it is 1 2 2 3 3 4 4 4 4 4. All right, now you have to store its frequency map. Now what you can do is, you can construct an array with on in here is an index, and here is count. So on the first index, on 0 index, you can leave it as empty, and on the first index you can there is no 0, so the count will be 0. Then comes 1, and there is 1 in the array, so you keep 1. Now there are you go to 2, there are 2 2s in the array, you keep 2. There is a 3, you keep, there are 2 3s, and there are 5 4s. All right, so here what happens is that either you can do something like this, that this is an array and you are keeping these numbers, so the final frequency array will become something like 0 1 2 2 and 5. But the problem comes when these numbers become large. Now let's say the number was something like sort of this, then how many indexes will you store in that array? 4 into 10 to the power 7 times. That would make the array quite huge. All right, for that purposes we use a map. What map does is, a map will store key and value pairs, and it will be something like, since 0 was not required here, so it will not take up 0, it will just keep this thing as key and value pairs, like this. So this is what a map does. All right, so how we will use the map is something like this. It is implemented as, for auto I in A, where A is the name of the array, we increase the frequency of that I by 1 whenever we encounter that I in the array. And for the code, I can show you something like this here. You can start with an unordered map. It takes, the key is also the int, the value is also the int. We give it a map mp with the name mp, and let's suppose there is an array. 1 2 2 3 3. So you can do this, and by this it means that by default the starting of MP of I will be 0. That is, the first time it is encountering 1, the MP of 1 will be 0 by default, then it will increase it by 1, so MP of 1 becomes 1. Next time it sees 2, that is I becomes 2, MP of 2 becomes 1. It again sees 2, MP of 2 becomes 2, and so on. Alright, this is how we use a map. And for printing a map you can do something like this. So here you can see 3 is 2 times, 2 is 2 times, 1 is 1 time. I dot first is the key, I dot second is the value. Alright, is it making sense to everyone? The map is totally unordered, so you can get any order in that. If that was an ordered map, that is simple map, then there would be some sort of ordering in them, that is, the keys would be sorted. See, did you get my point? Alright, so we'll move on to the this is our first quiz, and in the first question you have to find the product of array except self. Now let me explain to you what I mean to say here is, let's take this array. So array here is 1 2 2 3 and 3. Now what you have to do here is that you have to output an array such that on the first index is the product of all the elements except the first index. That is, the first index of the output array will be, the first element of the output array will be 2 into 2 into 3 into 3, that is 36. And the second will be the product of 1 into 2 into 3 into 3. You will not count this 2, so that makes 18. Similarly, the third element would be, we have to not consider the third element and multiply all the elements, that is 1 into 2 into 3 into 3, which is again 18. For the fourth element, do not consider the third one. The you can do is 1 into 2 into 2 into 3, that is 4 into 3 12, and similarly 12 again. Do you get my point, everyone? Now there is another twist in this question, and what is that? So your obvious first answer would be, you will multiply all of these numbers, right, and then divide it by the element which we are getting, right? You can just multiply 1 into 2 into 2 into 3 into 3 and then divide that product by this number, then divide it by this one, then you can 36 divided by 2, then 36 divided by 3, then 36 divided by 3, right? But the twist here is that you cannot use the division operator in your questions, and you have to give the answer in O of n time complexity. So that is the twist here, and that is what you need to solve today. Anyone would like to share their approach for this question? Anyone? Great. So could you elaborate on that a bit? Like, elaborate this for others, or let me elaborate from your point of view. So what Purav here is trying to say is that we will have two arrays. The one will have the prefix sum or the prefix multiply of the left array and a prefix multiply from the right side. There are two sides here, and both of them are converging towards a point. So what we can do here is, there will be a left array which will store the multiplications till the products till the L minus 1th element. So for the first element it will be 1 only. The second element we have to store till L minus 1th element, that is 1 into 1. Then for here the third element, it has to store for the first two elements, that is 2. For the third element it has to store till only the first three elements, that is 4, and then 12. Similarly there will be a right array which will store from the right hand side. So first of all is 1, then comes 3 again, 9, then 18, and then 36, and the answer will be 1 into 36, 1 into 18, 2 into 9, 4 into 3, and 12 into 1. So it is the sum of, like for example, you have to find the product for this element. It is product of this multiplied by the product of this. All right. Is everyone clear with that? Am I audible? समझ में आ रहा है? कुछ दिक्कत लग रही है? कोई भी प्रॉब्लम हो बताओ. कुछ नहीं समझ में आ रहा हो तो. हमने पहले 1 से स्टार्ट किया, फिर राइट से स्टार्ट करते, राइट फ्रॉम राइट वी आर मल्टीप्लाइंग ऑल द एलिमेंट्स. पहले 3 से मल्टीप्लाई किया, देन अगेन वी मल्टीप्लाइड विथ 3, देन अगेन वी मल्टीप्लाइड विथ 2, देन विथ 2. All right. So this will be the approach for this question, and I hope you can do it by yourself. If you need, tell me. I will also I had already written the code for this question. Let me show you. I'll explain the code also. So here, let's say the array was from 1 to 10. This is the length of the array, and we create a left prefix array of size 11 from 1, and of size 11 from the right. Then we start multiplying the numbers. So left prefix of 1 is left prefix of 0, that is 1, into array of 0, that is 1. So the array becomes then, first starts with 1, then 1, then 2, then 6, then 24, and so on. Similarly, here is a right prefix array which will start from the right hand side, and we will output the answers, that is the left prefix multiplied by the right prefix. Alright, then this is the same. Next we'll move on to the second question. In this question you have to print the element if it has the maximum frequency in the array. So how will you do that? That is, for each element print it if it has maximum frequency in the array. So like for example, this is the array here. So here 2 and 3 have maximum frequency, that is 2. So you have to print 2 and 3. Alright. Any approaches for that? Anyone? I hope the question is quite straightforward, right? So, am I audible? Well, you will have to use map. There is no other way. Or what you can do, there is also another way, but it will take a larger time complexity, and I'll cover that in a bit. So what you have to do here is, there is a vector. You make up a map for that. All right, and it can be unordered map, since we are not at all bothered with in what order they are stored. All right, and that will reduce our time complexity. So we take an unordered map, and we keep on uh, putting the elements in that, and their frequencies are being counted. Then what we do is, we create a variable max frequency and check that within that map, with what is the maximum frequency of any element, and we traverse the map again, and if any element has that maximum frequency, we will output that element. That is the key here. All right, is everyone uh, able to understand that? So yeah, now what would be the second approach here is, the second approach, that without using a map, here could be, you can sort the array. So uh, let's start with a random array first. So let's suppose this was the array. So first of all, you have to sort the array, and you can store the frequencies of all of them then, using that. This would be the sorted array, right? Now once this has become the sorted array, you can count the frequencies. That is, whenever there could be a variable frequency, and whenever the element changes, the value of the element changes, you can make this 0 and store this frequency somewhere along with this element. All right, and for whichever it is maximum, you can output the element. Am I clear? But the problem here is that sorting takes O of n log n time, and since it takes O of n log n time, it is slower, because an ordered map takes O of 1 time, and we traverse the array, so O of 1 in, and that is being done n times, so O of n time complexity, and we are here traversing the map 2 times, that is also O of n. So overall time complexity becomes O of n. Although here, since due to sorting, the overall time complexity was O of n log n. That's why the approach using unordered map was better and must be used. So secondly, we'll go to the third question. Thirdly, the queries on number of primes in the range L to R in O of 1. So this is very much similar to the prefix sum. What you do here is, you check for each number whether it is prime or not. So if you start with let's say 0 is not prime, 1 is not prime, then 2 is prime. Sort of, you can make an array of true and false. 2 is prime, 3 is prime, 4 is not prime, 5 is prime, 6 is not prime, 7 is prime. All right, can we make an array of true and false? For and yeah, so let us say that L to R is within 10 to the power 3, that is 1000, or maybe 10,000, then we can make, and we can do a primality test. How do we do a primality test is that we can, it takes an integer. If a less than 2, return false, and I less than root a. And if a is divisible by I, you can return false, else return true. And if something sort of like this, right? This is a primality test, and you can do it for all the numbers beforehand, from 1 to 10 to the power 4, whatever the range was given. Alright, and then you can create an array based upon these, and you can take f value as 0 and t value as 1, and you can create a prefix sum array, and that will be very much similar to how many that prefix sum array will give the answer to how many numbers there are within the L to R range. Alright, am I making sense? Are you able to understand? हाँ बताता हूँ. So last में क्या होगा, what happens here is you can make an array of f and t, right? That is, you will run a for loop for, let me remove this code first. You will run a for loop for that array, and I less than arr dot size I plus plus, and you will check if arr of I, sorry, arr is the array of bools. So let's say the range was total number we have to find were 10 to the power 4. So n nums is equal to this. If is prime I, then primes of I is equal to true. You can do something like this, and from this primes array you can create a prefix array, that is vector int prefix of nums plus 1 that starts with 0, and for I int if is prime I, then prefix of I is equal to prefix of I minus 1 plus 1, else prefix of I is equal to prefix I minus 1, right? So this is, you create a prefix array, and whatever the range you are asked, you give the answer by prefix of r minus prefix of l minus 1. This will be the answer to your query. All right. Am I clear to everyone? Any questions regarding this? So this is very similar. This is a very straightforward question for prefix sum. All right. And next we move on to sorting. So what is sorting? Sorting is used to arrange the elements of a container in a specific way. So basically, sorting is, you keep the numbers in the ascending order, but some of the times you may not need ascending order. For example, what if you wanted descending order? Well, the answer could be, you can reverse the ascending order. Now let's say my another question can be, what if you were asked that you have to arrange the elements in such that they're in the ascending values of their absolute value. Like for example, there is 2 and let's say there is 1 and minus 2. So in a normal ascending order, the values would be, first of all you will get minus 2 and then 1. But if I were to ask you that you have to sort them in the such that you have to arrange the elements based upon their absolute value, then obviously 1 will come before minus 2, because the absolute value of 2 minus 2 is 2 and 1 is smaller than that, right? Am I clear to you? बोलो. हाँ ठीक है. So how do we sort an array? Sort इसके लिए simple होता है. You can do it by with this way. Let me show you here the code for that, which is sort of vector, जो भी vector का नाम होगा, let's say array is the name of the vector, then this is how you sort an array. All right, which is very simple. But we also need comparators, because if we have to arrange in some custom order, we need a comparator for that. So the comparator of a sort function takes two values and decides which one should come first. So let's see. This is the syntax for sort function and sorting of a vector on an array. It sorts the elements from begin iterator to end iterator. Here this was the begin iterator for vector and this was the end iterator for vector. If there was an array such as this, like this, then the begin iterator would be array and array plus n, which is the size of array. Let's say n is the size of array, then this would be the begin and end iterators. Although it is better to use vectors, therefore I would suggest you to use vector int array, and for that it is array dot begin and array dot end. Also what you can do is you can create a preprocessor directive here for all, that is array dot all, which will store from array dot begin to array dot end. All right, so we'll not go into that. First of all, let's see what is a comparator. So comparator here is it sorts, the sorting function sorts element from begin iterator to end iterator, and it sorts based on the comparator. So you have to make a comparator function and give it to the sort function. So here comparator is a function. For example, here it will always return a bool value, that is whether true or false, and it gives compare, that is, this is the name of the function which you will give to the sorting function here. Then this is the data type that this function takes for first element, that is most probably integer, and second here integer. And then there will be some condition here, and you will have to return true, else you will have to return false. Alright, so when we will go into the implementation part of this, you will understand more about it, and I'll show you there. So this is the comparator, which is the default comparator for integers. So let me copy it here. Alright, one, this is the array, and array dot begin, array dot end. If we sort this, what should be the answer? The answer should be, wait, oh, I am not output, the answer so the answer here is this 1 2 2 4 5 5 7 8 9. Now let's make a comparator for it. Bool compare int a int b and return a less than b. So what will be the answer if I were to do this? Tell me your answers here. Will it be the same? Will it be reverse? Any other order? बोलो, कोई तो बोलो. Anyone? Make a fair guess. मेरी आवाज आ रही है? तो आंसर भी बता दो. करते हैं, चलो रन करते हैं. सेम हुआ. नाउ व्हाट इफ दिस आई do this change, what will be the answer now? हाँ, ये रिवर्स हो गया अब. ठीक है. नाउ वी मूव ऑन टू द नेक्स्ट data structure sort of thing is pair. Do you all know about pair, or should I give a brief revision about that? बताओ. Anyone here who has an idea of pair? हाँ. So pair is, let's say we make a vector of pairs. So pair is a pair of two integers, nothing else. So it will be, I can do something like push back. You can make a pair by this writing two integers within curly braces. Alright, and I'll input some random pairs here. All right, so I guess this is okay. Cout array dot first, dot second, and कुछ गलती करती सी आउट ठीक. So here, as you can see, the vector is sorted based on pairs. So it is 1 2. You can see the first, it is sorted based upon the first element, right? Can you see it here? So what happens here is, let me show you the comparator of a pair. So if a and b, that is if the first element is same, then it sorts based upon the second element. If they are not same, then it sorts based upon the first element. So here, like 2 was same in this, 5 and 6 were different, so it sorted based upon the second element here. This is how it is sorted by default in a pair. So we'll make a function similar to this, pair int a, pair int b, this is the default comparator. Now if I were to ask you that, rather than on the basis of first question, sorry, the first number, you have to sort based on the second number, what you would do then? Rather than based upon the first number, you have to sort based upon the second number, what will you do then? That is, पहले 1 3 आना चाहिए, देन 1 7 आना चाहिए, देन 2 5 आना चाहिए, पहले 3 1 आना चाहिए, फिर 7 1, देन 2 5, देन 1 6 एंड देन 2 6. हाँ, तो एग्जैक्टली जहाँ पर सेकंड है वहाँ फर्स्ट हो जाएगा, जहाँ फर्स्ट है वहाँ सेकंड हो जाएगा. So we will replace, so if they first we will base upon second number, and if the second number is same, then we will sort based upon the first number. And if I were to sort this, it gets sorted. All right, now let's say I do this, what would happen? Let's run it and see what happens. So did you see any particular thing here? Yeah, yes, because we are not at all bothered with the second element here now. All right, and this can happen, and this you may require this. So this is some sort of thing, and next we will delve into what So why not do it here, if you are asking that. So yes, yeah. Now this brings me to a very good topic which Jyotirmay just said. And what happens is here is that what Jyotirmay said, that if we change the order in which the elements appear, will it change the order in the sorted array? So it may change, it may not change. All right, that is uh, the main question here, and it is uncertain if you are using sort. And in those cases what we do is we use we use another function which is named stable sort. With this you are certain, with absolute certainty you can say that if two numbers are equal, that is here 2 and 2 were equal, then they will be ordered in the way they appear in the original array. So this time also the order will not change, and this is a good thing which we can notice here, and you may use it, although it is not much used, but yes, it can be used at various places. And another thing here is that which I would like to add upon this is, what if a dot first and is equal to b dot first? What should the compare function return if two numbers are same? So if you write this less than equal to, then it will return true if two numbers are same, right? And according to the standards of C++, you should not do that. C++ explicitly says to its users that if you are making a custom comparator function, that then if two numbers are equal, then the compare function should return false. Alright, so whenever you are making a compare function, always keep in mind that for two similar numbers, that is numbers of same value, the answer is false. Okay, because you may get erroneous results, like something like here which was erroneous. And am I clear to everyone? So we can move on then. First of all, write a comparator to sort the array by the absolute value of an element. So this was what I discussed before, that you have to make a comparator function to sort the array by the absolute value of an element. And how would you do that? Any approaches for that? And what should we write in the compare function? Abs a less than absolute of b. Great. And this is what we should do. And if it was -1 2 -2 1, the answer should be -1 1 2 and -2. Then we move on to our second question, which is sort an array by the second element and then the first element. We have done this and it is simple. We can just exchange the first and second word here and the answer will get changed. Now the final, sort an array by its frequency in the given array. This is the main question which we will be talking about here in this quiz. And any ideas for it? What can we do? Absolutely. Yeah, we can make a map first of the array, and then in the compare function we will write the map. We will write it in. We will compare the values from the map. All right, and according to that we will get the answer. Sort function for a map. The map sorts based on keys and not based on values. So if you are talking about a map which is an ordered map, then it orders the map based upon the keys rather than based upon the values. So that would not make sense for us. So what you can either do is, either you can invert the keys and value pairs, or you can write within an, like we are doing here, within an array. All right, using an array. So here in the comparator function we will rather than apps, we will check the value in the map. So next we move on to binary search. I'll just give a brief intro about binary search. I'll not go into the implementation for it. So this will be mostly covered in the next topic. So binary search is used for sorted collection of data. It is a searching algorithm, and there are various flavors of binary search, like something like ternary search, something like Fibonacci search is also there. But the main algorithm used is usually binary search, and what it does is it divides the range to search by half every iteration. So if there were 10 to the power 6 elements and you had to search for an element, then you can do it just in 20 iterations. If there were 10 to the power 9 elements, then how many iterations would you need? Can someone tell? For 10 to the power 9 elements. How much? 30. Yes, that is a fair estimate. There would be nearly 30 iterations, and so that is the power of binary search and how useful it is. And its time complexity is O of log n, as we can see here. So this is the implementation for it, and we will not delve deep into that. But as an overview for that is, you are given an array, you are given a target that you have to find, that is the index maybe, or whether this target is in the array or not. So you have a left pointer which is 0, you have a right pointer which is the last index of the array, that is a dot size minus 1, and till left is not equal to right, you do this function with the function here is mid is equal to left plus right by 2, that is you set a mid value within which is the average of left plus right, then you check whether that value is equal to the target. If it is equal to the target, you return true. If that value is smaller than the target, then obviously the target will lie on the right hand side. All right, and that's why you make left is equal to mid plus 1. On the other hand, if that mid value is smaller is larger than the target, then obviously that target lies to the left of that mid value, and you make right is equal to mid minus 1, and you do this until left is less than equal to right, and if no such element is found, then you return false. So this is how it is used. And can anyone of you point out a mistake in this code? Something that we recently posted on Instagram about. A major flaw in binary search. Can you see it here? Anyone? Yeah. So this int mid is equal to left plus right by 2 may be problematic at times, and if the numbers are huge enough, then these numbers can overflow, and therefore I recommend you to use left plus right minus left by 2, which will be the same as this expression, although it will avoid overflows. So we will end our class here, and we will go on to binary search in the next class along with 2 pointers, which will be taken on Wednesday by Nishchay Shroff. Any other questions that you would like to ask to me? Anyone? All right, then we will call it a day then. Thank you, everyone.